Okay, so we are back to Euler. He comes up everywhere. And the now he's coming up in number theory, and we're going to talk about the Euler phi function or phi function. So phi of n is the number of integers, of whole numbers, less than n, such that x less than n is relatively prime. With n. So there's a few kind of very natural things that we'll note. Clearly, phi of n is going to be less than n. Also, phi of p is going to be equal to p minus 1. This is going to be the most common, or this is pretty easy to check. So because p is prime, every single value less than p is going to be relatively prime to it. Therefore, it's just going to be all the values less than p. If we have phi of a times b with a relatively prime to b, then phi of AB is equal to phi of A times phi of B. So this is going to come up with you're calculating a lot of stuff on your last homework. And the last very useful thing to know is that phi of p to the k is equal to p to the k minus p to the k minus 1. So basically this is just going to give us a number for all of the multiples of p that are less than it, because those are the only thing that will be not relatively prime to it. Anything that is a multiple of p. Also, we can check back up here. This is just p to the 1, right? So this is equal to p to the 1 minus p to the 0, because p to the 0 is just 1. So this is just a special case of that. So what's nice about this is we can break something down to the prime factorization of it. So let's say I want to know what phi of 100 is. Then I can break that up into, actually let's make that 1,000. So that's phi of 2 to the third times phi of 5 to the third. So what is 2 to the third? So that's going to be p to the k, so that's 2 to the third minus 2 to the 4. And these guys are clearly relatively prime. So I can apply this little theorem right here. So I can do this. This gives me 4 times phi of 5 to the third is, so that's 5 to the third, or 125, minus 5 to the second, which is 25. So that's equal to 100. So this right here should be equal to 400. So this is going to be a good chunk of the calculations in your homework, and it falls out pretty easily. Also, this right here, we need them to be relatively prime for this to work. So if they're not relatively prime, then you should be able to come up with a counterexample. I think I'm going to put that on your final as one of the questions. Come up with a case where 5a times b is not equal to 5a times 5b. So basically just scour to find two ones that are not relatively prime, two numbers that are not relatively prime, and then you should be able to check it out to make sure that it works.